we talked about the unique bus stack, and we talked about briefly how the breaker just merely ratchets onto the bus stack using a straight blade screwdriver. All of these photographs kind of give you different angles, different views of what that bus stack looks like, and each one of them kind of goes through the process of how easily it is to install an I-line breaker. So if we start with the upper left-hand photograph, in this case the person is taking that breaker and merely just kind of sliding the breaker onto those bus bars. You're not actually connecting to the bus bars, you're just aligning the stabs. You can see the stabs there on the breaker itself, and you're just merely aligning those stabs with the bus bars so that when we do begin to ratchet the breaker onto the bus stack with the screwdriver, those stabs are properly aligned on the bus bar. Once you get it lined up, and in this photograph here, they now have the breaker lined up, you merely take the straight blade screwdriver, you stick it through a rectangular opening, and you can see the rectangular opening right over here in this illustration. You slip the straight blade screwdriver through that rectangular opening, and then you can see these cutouts that I've mentioned a couple of different times. And this illustration shows them pretty well. In this case, there's 4 rectangular cutouts, and what the user would do is they would merely take that straight blade screwdriver and they would put it in the first one. They would slip the breaker on a little bit, move it to the next one, slip the breaker on, merely ratchet the breaker on. And once they get to a certain point, once these stabs are fully engaged with the bus bars, the breaker will not go any farther. And the way that the breaker is designed, if we look at this illustration over here, not only does this shroud protect the shroud or the bus stabs, but actually it keeps the user from overexerting those stabs onto the bus bars. So once they reach a certain limit, the breaker won't go any further. And once they get the breaker into position, then you can see in all of these illustrations, there is the screw or the bolt that then would go into the round cutouts in the mounting pan. They tighten that down, and they're finished with the installation of that breaker. Like I say, we typically estimate 20 seconds to install the breaker. No bus connectors, no loose parts to be lost. When you have a customer that has an existing I-line panel board and they want to add a new breaker to that, the only thing that they receive is the breaker. Everything is attached to the breaker. This is a captive screw. It has a captive washer on the back side of that mounting foot. You actually have to pull that captive washer off of that screw in order to remove the screw. So it will not come loose. Our competitors cannot make that statement. Our competitors have bus connectors and they have many other loose parts. The other thing that I want to mention is this statement that talks about blow-on construction. And you can actually Google that, because what you've got on this I-line breaker, and this angle makes it a little bit difficult to see, but you have a plug-on jaw that goes above the bus bar, and you have a plug-on jaw on the breaker that goes below the bus bar. So you have one on top and one on the bottom of the bus bar. As current flows through those plug-on jaws, there's a magnetic field that is induced around each of those plug-on jaws. Those magnetic fields are attracted to each other. They're attracting magnetic fields. So during normal conditions, those magnetic fields are not so substantial. They're not so significant. But when you have a fault condition, Obviously, with a fault condition, you're going to have a high surge in current. With that high surge in current, you have an increase in those magnetic fields, and it causes those jaws to actually grip the bus bar in a tighter fashion than normal. It's called blow-on construction as opposed to blow-off construction. So during fault conditions, the plug-on jaws of the breaker actually grip tighter than during normal conditions. I already mentioned the flexibility, and in this particular statement, it's referring to frame sizes. So in this case, what it's saying is a 100 amp frame breaker can be installed directly across from a 1200 amp frame breaker. And I mentioned earlier I could take an R frame breaker and mount it directly across from an H frame breaker. Well, you know that an H frame breaker, the minimum trip rating is 15 amps. So I can mount directly across from that 1200 amp R frame breaker a little 15 amp H frame breaker. Our competition can't make that statement.